Hey, welcome back to Fat Mama Physics. In this video, we are going to go over more examples that have to do with peeling the onion when you get a complex equation to solve. So again, I'm going to do one example, you do one, I do one, you do one. Okay, these are the last examples. So last video in this section here, okay? Notice we're now dealing with some radicals and some squares. Ooh, okay, let's try it out. So let's start off with example 7. Okay, now yes, we are trying to peel the onion again. Now in this case, we have everything underneath the radical sign. And if you kind of remember what, if you think about it, everything under a radical sign, you can imagine it as it having some brackets. So the w plus 8 is a bracket, and the radical sign kind of goes above those brackets. So to peel the onion, to get to our variable, we have to get rid of the radical sign first. And we know that the opposite operation of taking the square root is taking the square. So we're going to square both sides of the equation, just like that. And as a result, this square gets rid of this radical sign over here, and then we're left with 7.3 squared is equal to w plus 8. Okay, 7.3 squared, we can check that on the calculator. 0.3 squared, 53.29. 0.29, double check I have it. Is that the right number? 3.29, okay. And now we are now left with just getting to our w, which, peeling our onion, we need to get rid of the 8 as a term. That's a constant. Getting rid of this 8, I'm going to subtract it on both sides of the equation. I am left with w is equal to, whatever this is, 45.29. Okay? And that's our final answer right there. Okay, not too bad, right? We're going through all the operations, eh? Now, good. You're going to do example 8, so good time to pause the video. Okay, now it's, let me go through it with us together. Again, you have a very similar situation where, again, we need to kind of get rid of this radical sign because we have some brackets here on the inside and radical sign needs to go. Now your first impulse might be to try to calculate what is the square root of 2.8. Guess what? This is where shortcuts tend to come into play because we have to square both sides of the equation anyways to get rid of this radical sign with the on the variable side. So I have to square this side. I also have to square the other side of the equation. And guess what? The square here cancels out with the radical sign on the other side of the equation. I am now just left with 2.8. And that's equal to this square here cancels out with this radical sign. I get 8 minus w. Okay? Oh, that was very nice. I didn't even have to calculate what square root of 2.8 was. So now we can isolate for our variable by peeling the onion, getting rid of the 8. But wait a minute, this w is negative. So maybe I should move to the other side first. Okay, so I'm going to plus w, that gets rid of it. Here I get 2.8 plus w is equal to 8. Now we're going to peel the onion, okay? Getting rid of 2.8 over here, and minus 2.8 on this side. And I'm left with w is equal to 8 minus 2.8. That's going to give us 5.2. If I did my math correctly, I can check. 5.2 plus 2.8 is going to be 0. So yes, that's right. Okay, there you go. Wasn't too bad, hey? Alright, so I'm going to do example 9. Example 9, take a look. There is a square right outside of all of my variables that are on the inside. So again, I'm going to peel the onion. I want to get rid of that square, okay? So the first thing I'm going to do is to get rid of the square by taking the square root of both sides of the equation. So imagining I am bracketing this, taking the square root, bracketing this, taking the square root. Okay, so I get the square root of 3.9. this is equal to the radical sign gets cancelled, the square root cancels out with the square. I am just left with 3x now, okay? I'm left with 3x. So if you would like to, you could go ahead and calculate the square root of 3.9. Let's do that. I get 1.974, blah, blah, blah. You know what? It's just a lot of digits. And because I have to round this number, then I might not get a true value at the end. So it might be better to save the calculations until the last step. But if you would like to, I'm just going to write this out. But keep in mind, it'd be good if you kept all of your digits, okay? Keep all your digits. Don't round until the very end. And this is equal to 3x. Yeah, and you're right. To isolate for the x, you divide both sides of the equation by 3, just like that. Bam, bam. Then I get x is equal to. And notice that this number, 1.97, blah, 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 is in my calculator already. Good idea to save it somehow so you don't lose it. Divided by 3. That way I hold true to the value. 0.65828. Looks like I have a 0 right there, so I'm going to keep everything after the 0 because it's pretty true to our value. And you know what? I'm just going to put x on this side. This way it's easier to read for you. 0.6, what was the number again? 5828. 5828. Okay, there you go. There is my answer. You can put ... if you want. All right, example 10. It is your turn. Good time to pause the video and try. Okay, so let's do it together. Ooh, this one looks a little bit trickier, but you can do it. Here you have, again, the 3x plus 1 in brackets and all of it taken to the power of 2. So, again, we're going to peel the onion. We got to get rid of everything on the outside first by taking the square root, just like that, okay? And so I have square root of 3.9. And you know what? I'm too lazy to calculate this. I'm just going to leave it in there. This square root gets rid of that squared. I get 3x plus 1, just like that, okay? If you're thinking, ooh, there are more layers of this onion to peel, you're right. We got to keep peeling it because we got 3x plus 1. This 1 is a term by itself that we need to move to the other side first. We're going to peel the outside, peel the other terms. Peel this term here, and subtracting 1 on both sides of the equation, I get square root of 3.9 minus 1 is equal to 3x. Okay. Now I kept the square root of 3.9 because I didn't want to write all those numbers out. Okay. If you want to, you could solve it now, or my preference is to do all the calculations on my calculator at the last step. Okay. So what's next? I have 3x. To get rid of the 3, we have to divide, just like previously. We divide. Okay. So this goes away, and then watch. I'm going to flip it. My x I want on my left side, or for you and the camera is probably the opposite. So I get x is equal to square root of 3.9 minus 1. And this is exactly what I was trying to tell us all the time, is to make sure you bracket the other side, then apply your operation. This is very important now because guess what? I need to divide every term on the other side by 3. This is exactly where a lot of students will screw up. They will maybe divide the minus 1 by 3, or they will only divide the square root of 3.9 by 3. They only do it to one term, but they forget about all the other terms in the equation, and this is a very, very, very common mistake. So this is why putting in the brackets is important. You're doing the operation to the entire side of the equation. Super important, okay? So here, this is what I would show in my work if I were to do that. I would put the entire top as something as a fraction over 3, or divide the entire top by 3. Okay, so that's what I would do. On my calculator, what would that look like? Now, some of you have more advanced calculators, some of you have less advanced calculators like mine. here on this computer. So here, let me show you what that looks like. If I were to do all of this on the calculator, watch me very carefully and assume that I cannot use brackets. I don't see any bracket sign here. So let's do it. First of all, I have 3.9. I'm going to take it and take the square root of it, just like that. Notice I have 1.97 blah, 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 just like before. Then I'm going to subtract the 1 first, okay? So it's like I'm doing everything on the top first. I do that all first, okay? I subtract the 1. I get 0.97, and that looks reasonable. That's just 1 less than before, right? And notice what I did was I pressed the equal sign. So I told the calculator to spit a number out for me, okay? That's very important because the calculators sometimes do bedmass internally, so it might not be exactly what you want. So you just keep the steps rolling in the calculator, which will be helpful because this is the number that I want to divide by 3. Okay, now I divide by 3. I get 0.32494. This is the correct way how you would do it on a calculator. Of course, if you could put in brackets, then it will make your life a lot easier. But I know some of you don't have calculators that you can put in brackets. So this is how you would do it, okay? I get 0.3249, and guess what? This 9 here is pretty high up. It's very close to the next point up on the thousandths place. So I'm going to take the 9, I'm going to round the 4 up to 5, 0.325, 0.325. And you know what? If you don't round it to exactly what I'm doing here, I'm not going to count it as wrong, but you want to try to stick true to the value as much as you can if you have these decimals that follow. And because the 9 is pretty much can bump the 4 up to the 5, it's very close to the next number, so that's why I chose that. So there you go. This is example 10. So hopefully you learned something in this video. Hopefully you learned something in the series of videos that will help you do your algebra at home. Thank you for watching. Fat Mama Physics signing out.